This is the IEEE Computer Society Distinguished Lecturer Webinar Series brought to you by the Distinguished Visitors Program. The Distinguished Visitors Program delivers tools for individuals at all stages of their professional careers through visits to chapters, offering opportunities for individual interactions, and to the membership through webinars by respected professionals. We have distinguished visitors around the world who cover machine learning, cybersecurity, robotics, big data, cloud computing, blockchain, and cryptography, among others. Chapters can request a distinguished visitor on computer.org/distinguished-visitors. The Distinguished Visitors Program is able to pay up to $1,000 for a visit to a chapter, but by working with other nearby chapters to develop a tour, that amount can be increased. So when your chapter is planning its next event, think of the Distinguished Visitors Program.
Welcome to our Distinguished Lecture Webinar Series, brought to you by IEEE Computer Society Distinguished Visitor Program and co-hosted today by the Geographics Activities Committee. My name is Fernando Bush, and I am the Region 9 Coordinator for the Computer Society Geographics Activities Committee and the IT Manager at the Smithsonian Tropical Research Institute in Panama. I would like to take care of some housekeeping tasks. You can ask your question in the Q&A panel. Dr. Mead will answer as many questions as she can following the presentation. When you are writing your question, if it relates to a particular slide, please do your best to reference that slide. The webinar is being recorded, and the slide and the recording will be made available after the webinar. Today's discussion is Lessons Learned from Industry, Government, Academic Collaboration in Educating Secure Software Developers. I would like to introduce to our speaker. Dr. Nancy R. Mead is a fellow of the Software Engineering Institute and adjunct professional of software engineering at Carnegie Mellon University. Her research areas are security requirements engineering and software assurance curricula. Nancy Mead Award for Excellence in Software Engineering Education is named for her. Prior to joining the Software Engineering Institute, Mead was a senior technical staff member at the IBM Federal System, where she spent most of her career in development and management of large real-time systems. She also worked in IBM software engineering technology areas and managed IBM Federal System Software Engineer Education Department. She has developed and taught numerous courses on software engineering topics, both at university and in the professional education courses. She has more than 150 publications and invited presentations. Dr. Mead, I would like to pass the floor to you.
Thank you, Fernanda. I'm delighted to be here with you and with everyone else who has joined us today. It's kind of interesting, when I started working in cybersecurity, which was around 1995, I was transitioning from working purely in software engineering and software engineering education. And people said to me, well, what are you doing now? And I said, oh, I'm working in cybersecurity. And this was 1995. And they would say, oh, what's that? I never heard of that before. Well, as we all know, now everyone has heard of it. Everyone is concerned about it. And we recognize that there is a real need to educate the people who are developing our software so that we don't see the kinds of break-ins and hacks that we see all the time. It needs to be recognized that cybersecurity isn't just something you do after software is fielded. It's something you need to be aware of and identify and mitigate those risks throughout the entire software lifecycle. So with that being the case, how do you educate people so that they're ready to do that when they start into the work environment? That's what we'll be talking about today. And that's an area that I've worked in for a number of years. So we've got a few topics. The first is kind of a historic view of software assurance curricula, for which I led the development and the associated outreach activities. This will give you an idea of the amount of elapsed time that it took to get from point A to point B. Then we'll talk about related bodies of knowledge and the associated curricula. And there are quite a few now. When we started, there weren't, but now there are quite a few. So that means there are choices. That's a good thing. We had a lot of lessons learned because we were kind of starting from square one in this journey. And so I want to share with you the lessons learned, what the challenges were, and what good things happened that allowed us to make forward progress. And then finally, I can point you to some resources and take your questions. So with that, I'm going to start by asking you a question. It always helps for me to be able to calibrate my audience at the start so that I try to stay on target with the remainder of the talk. So if you could check all that apply in this little polling question, that would be wonderful. And we'll wait for a minute for those results to come up. Okay, so we've got an excellent mix here. Of course, since I asked to check all that apply, it comes to more than 100%, which is fine. So we've got a mix of teachers at whatever level, university, college, high school, doesn't matter. Researchers, practitioners, and students. Excellent. So the first thing we're going to talk about is software assurance curricula. We started working in that area, and this was when I was at the Software Engineering Institute, from which I'm now retired, but still associated with Carnegie Mellon. We started around 2009 with the idea of developing curricula for software assurance. If you've ever seen me speak before, you know that the first thing I want to do is to define terms. And in fact, that's the first thing I do on any project, so that we have a common understanding of what it is we're talking about. So we define software assurance very broadly, but you'll see we didn't address every single area of software assurance. We started out working from definitions that were already being used by the government, by standards groups. And we modified them slightly. We just tweaked them a little bit to come up with the definition that you see here. And our focus was on software development. You can see this definition is so broad that it could apply to any part of the life cycle. The other thing that I point out in the very last sentence, it says we want to be able to recover from intrusions and failures. Our focus was definitely on intrusions. Not that safety isn't important, but what we recognized was that a whole lot of work had already been done in the safety area, and it was very good, but not much had been done in educating people to develop software that was more secure in the first place. So that became our focus area within the software lifecycle, looking at software development, especially the early stages, because by then, by the time we started the work, there had already been quite a bit of work done in secure coding. Very little from an educational viewpoint in the areas of requirements, design, analysis, those areas, the early life cycle. And of course, there had also been a lot done in the later phases of the life cycle when we're looking at maintenance, improvement, etc. The other thing I'd point out is that at that point in time, the supply chain issues that we're seeing now weren't as prevalent. So we also had an audience of developers, not so much acquirers. So with those caveats, this is the definition that we used. And that gets me to yet another polling question, and then I'll give all of you a break for a while. So question is, are you involved in development of secure software in any way, shape, or form whatsoever? Well, this is interesting. It makes me want to ask a follow-up question. So it says a lot of you aren't involved in it, but then I noticed we had a bunch of teachers who may or may not be doing development. We have some students who might not have gotten there yet. Presumably people who are in practice are more likely to be the developers. So we've got a mix here. Well, that's great. We'll talk about some resources that will be informative, but which you could also go to if you're currently developing software to be secure, or if you want to do it at some future point in time. So our work initially was sponsored by Department of Homeland Security. They were forward-thinking. They saw a need for work in cybersecurity. We had previously developed a fairly large website for them called Build Security In. I had led the development of that effort from a technical point of view, not the actual hosting of the website or fielding it, but the content. And with that in mind, we recommended that we should start working on a curriculum for developing secure software. Again, recalling that there were degree programs and courses in cybersecurity, but mostly focused on the later life cycle activities. So we started in this very ambitious project, and our goal was to develop both curricula and transition strategies. Because of our previous background in developing the curriculum for the Master of Software Engineering, which was used very widely, we thought we would start with a master's degree. And there were a couple of reasons for that. For one thing, most universities have more flexibility in designing a master's degree program than they do when they're designing a bachelor's degree program. They have more room to build the program the way they want. There are, well, at the time there was no accreditation for programs like these, but it's a little easier for a university to say, well, I'm going to add a master's program to my curriculum than to say, I'm going to add a whole bachelor's program. We were fortunate in that we had a lot of sources of material that we could build on. Department of Homeland Security had sponsored development of a body of knowledge, which was one of our sources. We had the technical work that we had done for the website, which I've already mentioned. We had an upgrade to the Master of Software Engineering curriculum that was done and published in 2009, that had several sponsors, and the leadership was at Stevens Institute of Technology under Art Peister at that time. And Then we had various curriculum guidelines that had been developed for software engineering. So we had all those documentation sources. What we then did was to do a poll, a small one, of industry contacts, mostly managers and executives and senior practitioners, to see what they thought, what characteristics they thought they needed in secure software developers. One of our goals was to try to stay grounded in how these degree programs and specialties might be actually used, and not just be in the ivory tower designing a curriculum. So it was a three-way partnership between government, our sponsorship, and other interested parties, universities, and I'll describe in a minute how we did that, and then industry partners, basically a group that we surveyed, and then they served as a review committee for us as well. Some of them liked what we did, some of them didn't, but that's kind of what you can expect when you're doing a large effort like this. So the first thing that I did was to recruit people to work with me. Some of them were staff members at the SEI. Many of them were faculty who I had worked with before. And we had participation from people with training companies. You'll see that later on. We had participation from faculty at community colleges. But to start out with, we had a core of SEI people and faculty doing the heavy lifting. And then we had reviewers, both government and industry reviewers, and people who helped us later in the transition. Probably, and this is kind of an eye test, it'll be easier for you to see when you get the actual slides. This is a timeline that shows all of the major milestones in the work that we did. And it's something that you can reference there. I think in this slide set, there are a few slides that are important. This is one of them. So we started with the master's degree curriculum. I'm going to talk about that in a little more detail. That was published in 2010. And we were fortunate to get endorsement by both IEEE and ACM. We then did a slightly less ambitious effort because we knew an undergraduate curriculum was probably too much to hope for. So we developed a set of undergraduate course outlines that could be used in a specialty. We developed a set of syllabi to go with the master's curriculum. Then we focused on community college education, which we saw as important, had folks from community college faculty helping us with that and building on their artifacts. And then the last product out of this series was a software assurance competency model, because we said, okay, if somebody's actually going to do this, what do we think they need to know? That was followed by a substantial outreach program. Maybe you can't see it, but we distributed the materials very widely. We had at least 20 papers that were published at various conferences, 7 reports, many talks. It's probably closer to 30 by now. Thousands of downloads of the material. We still have a LinkedIn group, although it hasn't been too active, of a couple of hundred members. And course materials and videos. The course materials, as I will point out later, are available for free download from the SEI website. So if you're a faculty member, there's a lot that you can use and it won't cost you anything. We integrated the master's curriculum into a number of course offerings at various universities and also into the training curriculum at ISC Squared. Later on, we integrated the community college recommendations into several community college programs, and I was a contributor to that, although certainly not the only one. And the full software assurance courses that we developed and made available are listed here under transition. And then there were a lot of materials that other faculty contributed to the SEI website, in which we subsequently made available. Every once in a while, when I'm talking to a colleague, I'll say to them, well, gee, this is really good stuff. How about if we make this available on our website so that other faculty can use it? And many times they're agreeable to that. So from start to about the time that we ended this initial transition for the master's program, you can figure, going from around 2009 to 2014. One of the big challenges, which continues, is that the field changes so quickly that 5 years is a huge amount of time in software assurance and software security. So we're constantly trying to keep up. And when you add to that the length of time that it takes to institutionalize things at a university and in practice, you wonder if we'll ever totally keep up. But that's one of the challenges we face in a rapidly moving field. This pretty much reiterates some of the things that I mentioned on the previous slide. The first and largest effort was the master's curriculum, and then a number of offerings at other levels, which were published as volumes in our series of reports. We looked at integrating the material into an information systems curriculum, published a technical note on that, and then finally the competency model. All of those are still out there. In the master's body of knowledge, we identified 7 topic areas. A lot of these will look familiar. Now, these did not correspond necessarily to courses. We used a standard method to decompose these knowledge areas into knowledge units and then topics. And these were the 7 main areas. As a master's degree program, if you were actually going to offer this as a full degree program, it would look something like this with preparation. We want people to have some level of background coming into the program, and this is spelled out in the report. There's a core set of courses, and then electives and a capstone experience. So the structure is not unlike many master's programs. Of course, the content would be somewhat different. You can map the content to existing programs and see what needs to be added if you were to do something like this. Now, in hindsight, reflecting on it, most universities were not in a position to say, okay, I'm going to suddenly start offering this program. The ones that were already offering master's degrees in software engineering or in cybersecurity would be in a position to add some courses and have a specialty. We mapped out one for a master's in software engineering, adding a software assurance specialization, and that looks like this. So we used the core curriculum that had been identified for 2009 and then added the core topics from our master's degree curriculum. By the time you got done with all of that, you basically didn't have any space for electives. But this actually did come to pass at a number of universities where the faculty were committed to doing this, and they had excellent support from the executive team at the university. And last but not least, and certainly not last, maybe it's first, they had an audience for such a course. So this was the Master of Software Engineering with the Software Assurance Specialization. And take a look at all of these areas. Think about the work you do, or your research, or what you're teaching. And the next question is going to be whether these resonate with you, especially the software assurance topics. Are these things that you're already perhaps involved in to some extent? So more work for you. Wow, that's great. So everybody says yes, some of these are relevant. It's a shame you have to construct these questions ahead of time, because I'd love to ask the follow-up question. As in, which one of these? But we won't have time for that. That's terrific. It's always nice when you know that your audience is interested in the topics that you're going to be discussing. So now I'm going to talk a little bit more about the outreach that we did with the master's program, and then we'll jump into what we did with the community college program. The reason I'm focusing on those two is those are the areas where we spent the most dedicated time in transition, and where I actually know what happened and can report on it. Lots of times we'll publish things, and we might see the number of downloads, which could be huge, but we don't get feedback on whether somebody's actually using it unless they've taken the time to tell us about it, or unless they have questions. So I mentioned all the slew of papers that we had done. These are some of the ones we did early on. There are many more additional. I suppose if I went back to my own list of publications, I could find most of them, but it's a large number, and certainly beyond this. We distributed the syllabi. We did that not just by posting it on a website, but by targeted mailings to people that we knew. We talked to faculty at conferences. We talked to faculty at military academies, military schools, people at NSF, the folks in our LinkedIn group. So it got pretty broad distribution. These are the places where it was integrated early on. Since then, a lot of institutions, universities have integrated pieces of this. By now, it's gotten to the point where I only find out about it incidentally. Usually, if I'm at a conference, somebody might come up to me and say, hey, I incorporated some of this into our program. Otherwise, it's hard to know, because in order to keep track of that, you basically have to assign somebody to go out and poll various institutions of learning and say to them, are you using this stuff? And that's another job in itself. So we know it was integrated, at least some of the material was integrated in a number of universities. By now, it's pretty widespread. You kind of have to dig down, though. Lots of universities will have degrees in cybersecurity, and you don't really know what part of the life cycle they're focusing on unless you go in and look at the curriculum for that university. And as you know, that can be a pretty large task to do that. So let's turn from that. And by the way, if you think of questions as we go through these topics, feel free to note them down, because we will have time for some Q&A at the end of this. So the second piece, where we spent a lot of time, was recognizing that lots of people get into software development who don't have bachelor's and master's degrees, and they're developing software that's being used in the field. So perhaps we needed to reach people who are going to community colleges. And we recruited some faculty to work with us on that. We came up with a set of course outlines, identification of resources, and we published a report which was in line with other community college report recommendations. Now, here we were building on existing programs. There are computer science 2-year degrees. So we were building on those curricula to see what it would look like if we incorporated software assurance. The list of courses, and we had to pick a target audience, so we picked students who were likely to transfer to a 4-year program, because we wanted to have some continuity, and we recognized that lots of times people who do a 2-year program in computer science are likely to go on and get the 4-year degree if they're interested and motivated. So that was our target audience from the point of view of developing the curriculum. So CS 1, 2, and 3, computer science 1, 2, and 3, already exist in 2 years computer science programs. We suggested some modifications to them to make them more supportive of software assurance. We then added 3 courses: Intro to Computer Security, Secure Coding, and Intro to Assured Software Engineering. Now, when you delve into these, you can see, as in any curriculum, there's a series of topic areas. And so you can take those topics and package them differently from the way that we did it. One of the challenges is that you basically do have to already have a 2-year computer science program in order to do a good job of this. Just deciding that you're going to offer a 2-year degree in software assurance is not an easy thing to do. As luck would have it, we were approached by an industry group. My counterpart was Girish Seshagiri at a company called Ishbi at that time, although as things evolve in the corporate world, I think the company has changed. But in any case, I was approached by Girish. He was interested in the idea of internships as a path for entry-level people to get a 2-year degree, do an internship, and then be able to start a career in developing secure software. He was working with a nonprofit organization that he helped establish called Success, Central Illinois Center of Excellence for Secure Software. Of course, we still had involvement with Department of Homeland Security. Department of Labor was very interested in this idea of apprenticeships. And then naturally, since I was at the SEI, that was a participant. And the first school that we identified that was interested in working with us on this community college was Illinois Central College. So you can see we had a complete set of participants from industry, government, and academia. Part of the work was to identify companies that would provide opportunities for the students to be interns. And then, of course, we had to get students, usually high school graduates, immediately after finishing their diploma. So we started, and you can see this overlapped some of the master's program work and then continued. So we had published the software assurance curriculum in 2010. We published this report in 2012, and it was out there. We published the competency report that I mentioned in 2013. Well, simultaneously, there was the meeting of the industry, government, and academic stakeholders, which I was not really a part of, out in Illinois. They formed a core group. And then in November of 2013, we had initial discussions. The nonprofit organized a steering committee, and we worked toward identifying a college that would be willing to do this. We were very fortunate in that we found a college that wanted to be in a leadership role. There were companies nearby that wanted to provide internship opportunities for the students, and with almost no advertising, there was student enrollment immediately. And then the following season, the student enrollment doubled. So it was really a good success story. One of the challenges that they faced, which I'll mention briefly, was that the faculty, you need to bring faculty on board who can teach this or develop existing faculty. They were fortunate in that they had to bring in one additional person, but everything else they were able to offer with the faculty that they already had. Now, this is what the program looked like in their implementation. And you can see the additions: secure coding, intro to assured software engineering, the 3 computer science courses. So it was the full program. It was really good. One of the challenges that they faced was that the students didn't quite have the preparation that we were hoping for. So it was a big jump for them to be successful in the program. Some of them did very well. Some of the others, it was kind of a mismatch between their background and the level of the courses. And then several other community colleges followed as well. Once again, we don't know exactly what happened because at some point we stopped tracking that, that data. I'm going to go quickly through additional bodies of knowledge and curricula because we were one of the early ones, but there have been a lot since then. And all of these have websites that I'm going to point to at the very end when I mention resources. So you can go out and take a look at all of these. A big one that's still ongoing is the NICE framework. That was a NIST activity that started in parallel with the work we were doing. A lot of our curriculum work fit what became the securely provision aspect of the NICE framework. They had a number of major topic areas, and that was one of them, which was heavily focused on the early development life cycle. They have ongoing seminars, conferences. They are now drilling down into involvement at the high school level, which I think is very good. And so I would suggest getting on their mailing list if you're not already. Certainly all the webinars and materials that they have are freely available. I think for conferences, you probably have to pay something, but it's nominal. And that's when we have live conferences again. And what an international effort that I've been involved in is called the Cyber Body of Knowledge. That was started more recently. It's being led by University of Bristol in the UK, and it's funded in the UK. It has 19 knowledge areas. It covers more of the full life cycle. So some of their areas overlap both the software assurance curriculum areas and the NICE areas. Recently, I did some work with them developing and identifying a set of case studies. And they also provide free materials for academic use. The cybersecurity curriculum effort was a professional society effort that went on in parallel. That was completed around 2017. There were a lot of workshops and focus groups. I don't know if they've had a follow-on effort, but the website for this is still out there. And 2017 is relatively recently. So the last polling question, are you folks familiar with these or other bodies of knowledge? And if there are other ones that you know about that I haven't mentioned, by all means, let me know, because I don't claim to have a complete list here by any means. Okay, well, I guess that's a good thing. You get to learn a little bit and you can see what else is out there. Now, and let me back up just for a second. Carrie reminded me that sometimes, so we have a yes. There's a little bit of a delay that I've been forgetting about when we do these polls. Excellent. So the lessons learned, I mentioned some of these. I'll touch on them briefly, and if you've been teaching, I know you've seen some of these. First of all, if you're going to do this, you have to have broad participation. You can't just sit in a vacuum and say, oh, I'm going to develop a body of knowledge today. Even if you do, that doesn't necessarily mean that it'll be accepted. Universities might not like it. Industry might not like it. Some of them may actively oppose it, which is not so great, but it does happen. And it takes years to develop. The good news is, if you're doing something like this now, You don't have to start from scratch. And I was hugely gratified to find the number of people who were willing to participate, in most cases as volunteers. So they weren't getting paid to do anything. It wasn't part of their job. They were just contributing because they thought it was the right thing to do. For curricula, going along with the bodies of knowledge, just producing it doesn't mean it'll be accepted. What we found was our curriculum, being a reference curriculum, was something that literally could be referred to, but not necessarily used as is. Those of you who teach know that if you're adding new courses and topics to a degree program, the first thing that people will ask is, okay, if you want me to add this, what should I take away? Because I only have so much space in my program to do this. And that's a difficult proposition. You might find that if you add all of these things, as we saw in our Master of Software Engineering model with software assurance added, well, the electives are out the window because you've just picked all your electives. In addition, once you have the body of knowledge, you still could have a year's worth of work to develop the curriculum to go with it. The good news is, right now, at least in this field, you don't have to start totally from scratch. And the other thing is you can build within your organization or institution, you can build your curriculum in a way that's suitable for you and your student audience. So accreditation needs to be considered when you're doing curriculum design. If you're going to do accreditation, you need, on the other end, accreditation criteria, and the visitors who actually come to the universities need training. The good news is there are benefits to having accreditation, and some of you may be familiar with the Centers for Academic Excellence. That's a designation in the U.S. by national security agencies, and it's a big boost to an academic program to say, hey, I'm a Center for Academic Excellence in cybersecurity. And quite a number of universities have this designation. Associated with that is a government program that benefits students called Scholarship for Service, where they get at least some part of their tuition reimbursed, if not all of it, in exchange for a commitment to work for some number of years in a government agency when they finish their degree program. Both of those are excellent. Accreditation, of course, is also good. From a faculty perspective, if you're not currently offering programs like computer science, software engineering, information systems, and I'm just thinking in terms of the kind of faculty that you need to have on board. It doesn't matter what the degree programs are called. You get the idea. If you don't have those kinds of programs in place, it will be very hard to field a program like this. You don't just decide, I'm going to offer this next week. Developing new courses is a lot of work for faculty. They want to be convinced that it's really something that is going to be beneficial. And you need knowledgeable faculty to teach the material. You can't just decide to offer a program and say, oh, well, I'll go out and bring in 5 consultants and that will take care of it. It doesn't. You can do that for some of it, but not all of it. The good news is when you have supportive faculty and a supportive administration, you can get to a success, and that's excellent. Industry can help. We've seen very good success with industry advisory boards that will say, okay, this corresponds to my needs. And sometimes there's a give and take. You may have to tell them, well, this isn't exactly what we'll be teaching this time, but perhaps that you can consider doing some training. And so that can be beneficial as well. And there can be other benefits such as donations of equipment and so on. Industry and government, well, industry executives and government executives expect a return on investment, whether it's monetary or in some other form. Companies want to use their own standards, not somebody else's. And government standards, although they're excellent, take years to develop. However, the good news is we already have a lot of them. Very often, adherence to standards and guidelines is required. And there is a lot of government support. These are some of the U.S. supporters. There are certainly other international supporters as well. For practitioners, they also have a concern with ROI, whether they're investing time, money, or both. They want to get something back. So I think in that regard, executive support is really needed in order for that to happen. Students care about whether their major is in demand by future employers. When I give a talk to students, one of the first things they want to know is, can I get a job in this field? And maybe they're facing a bunch of student loans and they want to know they'll be able to make a good enough salary to eventually repay the student loans. The good news is there are a lot of degrees to choose from, as well as industry training certifications. And in our field, there are a lot of degree offerings and specializations. So most certainly can be done. So to wrap up, the field moves fast, so it's a challenge. We're now seeing things implemented that we started working on years ago. It takes a lot of time and effort for it to happen. The good news is when all of the entities are engaged, government, industry, and academia, you can have really good success. And the beneficiary from a lot of this for educators is the students who are better prepared when they start in the workforce, and hopefully they'll be in a position to do lifelong learning. There's a lot that's going on. Some of these efforts continue to have multi-year funding. They're listed here at the bottom. And I found another interesting one, an NSF-sponsored effort out in Washington. It's one of the ones on this list of resources. So we've got the SEI educational materials and course offerings. Course offerings are obviously not free, but the educational materials and documents are. The SIBOC website, this is the UK effort, has a lot of material for free. Among them are case studies that we just worked on. So you'll find that under additional resources. We've got the NIST NICE effort, the Centers of Excellence, and then this Cybersecurity Training and Education Center is an NSF-funded activity out in Washington State. A book that a couple of us wrote supports a lot of the curriculum work, although the book was done after the fact, and it's the second book in a series on cybersecurity engineering. So with that, even though I've talked for too long, I would love to answer your questions. if there are questions.
Thank you, Dr. Mead, for your presentation. Still, there is no questions, but Faiz Ikra Mulia sent thank you for your presentation. So when the presentation show up in the Q&A panel, I will read it for you.
Okay. And in the meantime, here's my contact information. It's also in the slide set that will be made available to you. Feel free to contact me to talk about this or any other software assurance topic. I'd love to do that. Well, I would say that the attendees might have gone to lunch, except it's only lunchtime here in the Eastern time zone. So,
any other questions, Dr. Mead? You can type your questions in the Q&A panel so I can read it to Dr. Mead. If there are no more questions, I would like to take this moment to thank Dr. Mead, for her presentation today, and also like to thank all of you for attending. Our next webinar will be titled Solving Global Grant Challenge with High Performance Data Analysis by David Botter on September 9th at 11 a.m. U.S. Eastern Time. I see one question showing up. I will read it and then I will continue. The question comes from Samuel Denard, Dr. Mead, and he asks, why was tracking of community college progress not continued? Why was tracking of community college progress not continued?
well, so the question, yes, was why was tracking of community college progress not continued? We continued it for a while. And we had, I think, probably 4 interested community colleges. The challenge that we ran into was the community colleges who were interested in offering this kind of a program. Some of them were in areas where they didn't have industry support for internships, and we had kind of wrapped the internship idea around the coursework idea. And so it was difficult to get them off the ground. Now, the other thing that happened, which is to directly answer your question about tracking, is that you have to have somebody who's actually going to do the tracking. The colleges won't necessarily tell us what's going on. And at that point in time, we didn't have anybody. It's happened sequentially. For a while, we tracked masters in software engineering. And then the person who had been doing that for us retired, and nobody else wanted to pick it up. It was a volunteer effort. For a while, we tracked what was happening at the master's level. Same kind of thing. When the work was no longer being funded, there was nobody to do the tracking. And at the community college level, after I retired, some of the work still continued, but I'm not sure if it's still ongoing. I suppose that's a work assignment for me, is to find out if there is still work going on in this area. And I'll make a note of that and actually get back to you on that. It looks like there's another question.
Yes, I have another question from Hernan Nina from Universidad de Lima. What are the trends in software design security?
Well, that's a broad question. So we saw a lot in the secure coding area. Secure coding standards were developed and published. Books have been written on the subject. Training courses have been written on the subject. In design for secure software, there are certainly a lot of methods out there. Many companies have their own guidelines for how they will design software for it to be secure. At one point, there was a discussion of standards, but it became pretty controversial as to whether the Standards Association should be specifying something like that. And so there are lots of guidelines, but there are no standards that I'm aware of. And without the standards, it becomes very hard to track what individual companies are doing. I do know that the forward-thinking companies have their own internal standards for how software will be developed in a secure way, and they are implementing that. Having said that, we know by the number of hacks that we see all the time that it's not necessarily happening across industry, and it doesn't take many vulnerabilities for problems to arise. So yeah, there are secure software design standards that are out there and are being used within companies. They tend to be the forward-thinking companies, but not all of them.
There is another question. Yes, from Samuel. Has there been any assessment of the skill level of industrial commercial software developers?
Not that I'm aware of. In a broad way, no. And I can tell you from my experience, which of course is only my own viewpoint, is it varies very widely. When I look at some software products that are fielded, it looks to me like they haven't even been alpha tested, let alone beta tested. Now, there are companies and government entities that have competency requirements and expectations for certain positions. But as far as looking broadly across industry and commerce, no.
Okay, there is another question from Hernan from Universidad de Lima. What is the trend in the use of artificial intelligence techniques for secure software development?
Well, you know, artificial intelligence is such a huge research area right now. I've been exploring that area. The research that I wanted to do was supposed to have started last year. But with the situation that we've been in for the last year and a half. It's gotten off to a very slow start because my collaborators, I haven't been able to collaborate with them very well at a distance. We're kind of located worldwide at the moment. So I think that's a big area that needs to be explored in a number of different ways. On the one hand, we thought about using artificial intelligence techniques to help in training. And then we thought about more broadly about artificial intelligence and how secure software is that is being developed using machine learning. So I would say that is a very open research area. I'm not, if there are trends that are widespread, I'm not seeing them. What I'm seeing is that the work that is being done is not as visible as it could be, and in some cases it's been slowed down by the shutdowns and various situations that we've been in for the last year and a half, unfortunately. However, a lot of artificial intelligence groups have been stood up in that time period. There is now at the SEI, there's an artificial intelligence initiative. So I think we can expect to see more. And they actually had a workshop for software engineering educators that had artificial intelligence as one of its important topic areas. That was last week. Okay, well, I think we're done. I'd like to thank you for joining me and for hanging in with your questions. It's been a pleasure to work with everyone who's been on this call. And I hope you have a good rest of the day.
Thank you very much, Dr. Mead, for your presentation today. I would like to reiterate the invitation to our next webinar. Will be titled Solving Global Grant Challenge with High Performance Data Analysis by David Barter on September 9th at 11 a.m. U.S. Eastern Time. And from our Building Our Career series, we have the conference Emotional Intelligence on August 24th. The registration is now open, and we will be sending you the link to these future events along with the slide and the recording of this webinar. Again, Dr. Mead, thank you very much for your presentation today. And if you want to give us your closing words.
Okay, very good. Thank you. It's been a pleasure to be with all of you. The slides will be made available. Audience members, please feel free to contact me via the email that is in the slides. I'd love to hear from you. And thank you, Fernando, for moderating. Excellent.
Thank you very much and have a great day.